So I actually um, presented a title 2 days ago on probabilistic graphical models, an adaptive Bayesian network for classification problems. Um, you know, the essence of this is just provide an alternative way of classifying items into different groups using probabilistic relationship among variables. But you know what? In this video, even though in my presentation, I talk about how the Bayesian network can actually be used in classification problem in medicine, supply chain and the like, but the purpose of this video is just for weather classification. So because of that, I will quickly I'm gonna go into the weather classification. Give me 1 second. Particularly when you take a look at this example now, um, you come out in your house and you discover your grass is wet. Okay, and of course, there are two possible things that could be responsible. It could be rain, or maybe the sprinkler is actually navigated. Okay, so when you take a look at this, this is actually called node. Okay, and they are the set of the random variables we are talking about. If I want to find the probability of the joint of the random variables now, S is for sprinkler, R is for rain, and J is for grass wet. So I'm actually going to have the probability of rain. Okay, you can say the rain is standing alone. It doesn't depend on any other thing, right? Then multiply by the probability of the sprinkler giving rain and multiply by the probability of the grass wet. Okay, so giving the sprinkler and rain. So that is what I have here. And of course, this is a factorized form. Okay, and if I want to make inference, inference is more or less like making judgment. If I want to find the probability that the grass is going to be wet, this is going to be the expression for that. And I may also want to find the probability of the grass wet given rain. Okay, so I'll quickly go into the uh, Australia weather data because the purpose of our meeting, the purpose of this video today is basically, to show the audience how, um, predicting data, how it actually works. Okay, we want to use Australia weather data, and this is the way data appears initially, and the data has already been, digitized and dichotomized. And, based on the, by the time we use the probabilistic graphical model on this data set, we actually going to learn the structure of the network to be this. What this is trying to say is that the humidity at 9 a.m. okay, will lead towards to humidity at 3 p.m. Of course, if I want to determine the humidity at 3 p.m., it depends on humidity at 9 a.m. And if I want to determine the probability of rain tomorrow, that will basically depend on the humidity at 3 p.m. and the wind speed. Okay, before I give explanation about how each of these conditional probability table associated with each node is being computed, I think I'm going to call on my daughter Alia to actually give ecological explanation on how precipitation works in general. So Alia, so how are you? I think it's over to you now.
Yeah, so now what I'm going to be talking about is how precipitation works and how the water cycle works, and also like how you can predict if it's going to rain in the next few days or if it's going to rain in the next 24 hours, So I'm going to show my screen right now. Let's see. Okay, so over here I've got an image of kind of how the map looks when it's windy and how it basically looks. So I got a map over here that shows the United States of America. So as you can see, you can like see this like circle, kind of like circle lines. Now those circle lines represent winds, and I want to first start from like low pressure means that it's turning counterclockwise, and high pressure is turning clockwise. So in this area over here in the low pressure, it's going counterclockwise. So it's starting over here and it's moving counterclockwise. So as it's moving counterclockwise, it's gonna keep moving and moving and moving. That the wind is gonna get lower and lower. That's gonna be very cold in the area. So now let's look at the map, the place in Minnesota. As you can see, there's three lines in Minnesota. That shows that it's very low pressure. There's a lot of low pressure there. It's very cold there, and you're likely to get more rain because if it's windy, then you're getting more rain. And as you can see on this side, since it's high pressure, this side, this side over here is showing like hot, like these places are hot, like in Nevada is hot over there, in California is very hot, you know. So that's what that one is showing. So you're probably not gonna get that much rain in those areas, but in the west side, you're gonna get so much rain, and it's also gonna be cold. Now, I'm also gonna talk about how that happens, which is how the water cycle works. Now, I've got a picture of how the water cycle works. As you can see, it starts from the ocean over here. As you can see, this water, that water, the sun evaporates the water from the ocean and takes it, which is called evaporation. Now, when the sun takes the water, it turns it into liquid vapor. And when the sun takes those vapor, over here, the sun transfers to the clouds, and that's what they call condensation. Now, you already know when the sun takes the water from the ocean, it turns into vapor, then it goes into the cloud, then it keeps repeating itself by the sun keeps taking it over and over. That makes those little drops get big and big to be falling like rain and snow. So those vapor turns into little water that falls. And then as you can see, when the water first falls in the mountain, it up in the mountain, if there's a lot of snow there, it melts and fall back into the lake. Then the water from the lake goes underground water and goes back in the ocean again and repeats itself and works over and over again. Now, how snow work is when you get to the stage that the sun transfer the water to the cloud, those water, when it's very cold, the water turns into ice, little ice. Then when it falls like snow. But when it's not cold, like when it's hot, it's rain. But when it's cold, it's snow. So that's how the water cycle works and how to predict weather for the next few days.
Thank you so
Thank
much
you so much
for the beautiful presentation. Okay, I think we go back to what I was explaining the other time. Alias already given us an ecological explanation on how that work. But what I'm going to be giving here is just how the variables how they related probabilistically. So what I'm trying to say here, the humidity 30 about 30 point maybe 658% of the time we have the humidity at 9 a.m. to be less or equal to 60, and about 69% of the time is greater than 60. So take a look at that. You actually gonna see this is a random variable that is actually discrete in nature. You get what I mean, right? And of course, for humidity at 3 p.m. The humidity at 3 p.m. actually depend on the humidity at 9 a.m. And what we're trying to say here is that when the humidity at 9 a.m. Is less than or equal to 60, the humidity at 3 p.m. will also be less or equal to 60. That or call at 92.8 82% of the time. Okay, and so on like that. And of course, the wind speed has three categorization. At times, the wind speed could be less than 40, less than or equal to 40, or 40 to 50, or greater than 50. And you can see the probability associated with each category. And of course, we need the humidity and the, at 3 p.m. and the wind speed to determine the rain tomorrow. Okay, so what you see here is actually the chance of the rain tomorrow. The chance of the rain tomorrow, considering different kind of states of nature. Here you are looking at 92.34%, 1.14% of the time when you're going to have rain, when the humidity at 3 p.m. is less or equal to 60 and the wind speed is less or equal to 40. Okay, it is only about 7% of the time that we normally have rain in that kind of situation. And of course, if you take a look at here, when the humidity at 3 p.m. is greater than 60 and the wind speed is greater than 50, of course, there is a high chance there's going to be rain tomorrow. And so what I'm showing you here is what we call the Bayesian network. Okay, we actually have a graphical and, probabilistic way of describing set of random variables. Okay, so this is actually what we use in coming out with a prediction, okay, on whether there's going to be rain or not. Okay, so I want to say a very big thank you to Aliyah for shedding more light on how the ecological mystery behind the precipitation works. And of course, I believe when I call you next time, of course, you're going to do more justice to whatever we may want to discuss. Okay?
Yeah, thank you so much, Jack.
Okay. So bye for